Hello there, guys. This is Professor Roldan. Welcome back to another unit. We are in the unit of probability, chapter 11, in topics in mathematics. In this video, we're going to talk about 11.1. 11.1 is about empirical and theoretical probability. And so notice that we're actually going to be starting in worksheet number 3, okay? Worksheets numbers 1 and 2 are actual experiments. But in this video, we're just going to talk about the math behind and the reasoning behind these experiments and how it relates to theoretical probability. So let's get started. I want to start with some history behind probability. First of all, the study of probability came from pretty much studying games of chance, okay, by mathematicians of the Renaissance era. Okay, so this is something that's important history. So the study of probability originated from a bunch of people coming together to study games of chance so that they could win. And as more people studied this topic, more mathematicians got involved and started to produce the study of probability. So this came from the Renaissance era. Okay. And one of the more famous, many people study this. You can read this on page 633 if you want. But the person who took mathematics theory, okay, what we call pure mathematics, and applied it to these studies of chance and or games of chance, and started to formalize what we call probability theory was Jacob Bernoulli. So many consider the founder of probability theory. So the theory of probability has been attributed to Jacob Bernoulli. Okay, and he's from 1654. This is an example of guys from the Renaissance. And he was a Swiss mathematician, okay? All right, well, he said, well, why is this important? Because many applications, guys, costs of car insurance varies, right? So they determine through probability studies and mathematics risk factors because of your age or your experience or accident history, and your insurance premiums go up. Probability is involved in weather forecasting, and if it's going to rain, or the probability of a hurricane hitting, things like that. And businesses use this, of course, to make decisions. We also have medicine, elections, manufacturing, educational tests, measurements, genetics, investments, opinion polls, natural sciences, all kinds of stuff. So lots of great applications in life, but we're just going to do the very, very basic introduction to probability in this course. So we're going to start with calculating simple probability of empirical and theoretical probability. So let's get started with that. So first of all, I want to talk about what is an experiment, okay? So an experiment, okay, and this is based off the first two worksheets. An experiment is basically a controlled operation that yields a set of results. Okay? It's a controlled operation that yields a set of results. For example, pulling marbles out of a bag or a chip out of a bag, if you have various things in there, rolling a die, or rolling two die, which is called dice, or pulling out a card from a deck of cards, probability of having a boy or a girl, if you have one child or two children, three children. So we can take a look at all kinds of experiments, and what we're looking at in those experiments are the outcomes. The outcomes are possible results of an experiment. Okay, outcomes are possible results of an experiment. Okay, which brings us to empirical probability. So the probability that we calculate in these experiments will be empirical. In other words, they come from observations, that you're actually doing the experiment. Okay, it's not theoretical. It's not on paper. It's actually, you're performing the experiment. So this is called, formally speaking, is called the relative frequency. The relative frequency of occurrence. How many times does something happen when you perform the experiment? So if you're flipping a coin, you got heads or tails. How many times did the heads come up? How many times did the tails come up? Let me erase that. Okay, so what is an event? Because you're going to see this word a lot. An event, okay, so we're talking about occurrences of an event. Well, what's an event? Event is a sub-collection. Actually, let me put this over here. Sub-collection of outcomes. Okay, so flipping a coin and getting getting heads is an event, and the other sub-collection of an event would be tails. Oops. Okay, if we're talking about having children, it's having a boy or a girl. If you're talking about rolling a die, you can roll a 1, 2, 3, 4, 5, or 6. Those are different events that can happen, okay? So this weird guy over here, that's not P times E. That's actually algebra terminology, and it's called P of E. P of E. And really, we don't even talk like that. That's algebra, but in probability, we say this is called the probability of an event occurring. Okay. So the probability of an event in an empirical study would be the number of times an event E has occurred over the total number of times the experiment was performed. Okay. For example, if I flip a coin 10 times, that's the total number of times that the experiment was performed. Let's say for my heads, I got 3 heads, and the other 7 times were the tails. Well, that means that the probability of the event of heads occurring was 3 out of 10. The probability of tails occurring was 7 out of 10. Okay? So you're performing an experiment and you're producing numbers. You have total numbers and you have particular event numbers, and you put the event over the total. Okay? So notice, guys, this is experiment, and we know the theoretical probability, which means, what are the chances of flipping heads or tails, or heads, and what's the probability of flipping a tails? Well, we know that's 50-50. You have 1 out of 2. Well, that terminology is actually talking about theoretical probability. So theoretical probability this is actually the study of possible outcomes. That can occur for the given experiment. Okay, the study of possible outcomes that can occur for the given experiment. Well, so that would be the number of outcomes favorable to event E. Okay, so for one coin, I have one side that's heads, and then one side that's tails. So that's why we say 1 out of 2. Well, down here is the total number of possible outcomes. Okay, so if I use the same example, to flip a coin, theoretically, the probability is the same for both. We have one side that's head and two sides, and the probability of tails, same thing. Okay, they both have the same opportunity. They both have equally likely outcomes. Okay, but that's in theory. Okay, so you can see the difference between experiments and theory. So let's say here, 3/10 is 0.3 or 30%. So 30%, that was my frequency for heads, and then here would be 0.7 or 70%. Well, that's not 50%, because down here, that's 0.5 or 50%. Same thing here. So there's a difference between empirical and theoretical. Why are they different? Well, theoretical is just talking about possible outcomes favorable with possible outcomes total. And this is, we actually have something called the law of large numbers. And the law of large numbers is going to basically tell us that if we do a bunch of experiments, if we do a bunch of these, okay, let's say we do sets of 10, and we do it over and over and over and over and over again, and we do a bunch of flips or tosses, it's going to get closer and closer to the 0.5 or the 50%, okay? So this is the law of large numbers. So basically, you can read the definition on page 637, but basically as you increase the number of experimental trials, of an event, the empirical, so here's what happens. If you do a bunch of trials, the empirical probability is going to get closer and closer to the theoretical probability. Okay? So empirical is just about experiments, basically, and theoretical is just if you did it over and over and over and over again, 100 times, 1,000 times, 1,000,000 times, you're going to get closer and closer to 0.5. Okay? And so we just kind of skip all that, and we just go straight to theoretical probability. Okay, so next we look at some important facts, and we have here the probability of an event that cannot occur. So if it cannot occur, then it's just not going to happen. It's basically impossible. So we have the number representing that will be 0. Okay. The probability of an event that must occur with certainty, 100% certainty, that's a 1. Okay. So this is telling us that every probability is a number between and including those two numbers. So 0 the probability of an event can be equal to 0, greater than 0, and anywhere in between here, between 0 and 1. So it could equal 0, it could actually equal 1, or anywhere in between. So just to kind of look at this in a number line, okay, so so here we have basically impossible if the probability is 0. We have certain, or that it must occur. And then so that's then we have in between, basically we have a 50-50 chance, right? That's why we say that. If you're right in the middle. And of course, we have, anything close to 1, I would say over here somewhere. This is likely to occur. Over here somewhere would be definitely unlikely. Doesn't mean it's not going to happen. It's just unlikely. Okay. All right. So that's kind of the lowdown on that. And now we have, I want to talk about one more. So let's see, we can use some room over here. So the other one, so let's talk about so all the possible outcomes of an experiment. Okay, let me give you a clue what I'm about to write. So if you look over here, we flip the coin 10 times, and notice that the 3 plus the 7 is 10. 10 out of 10, okay? Notice that 0.3 plus 0.7 is 1, okay? And over here, 30% plus 70%, that's 100%. So in each case, my experiment of tossing or flipping the coin 10 times obviously is going to add up to, our probability is going to add up to 1. So here it is right here. So the last one that's not included here that I would like to include is that the sum of the probabilities of all possible outcomes of an experiment is equal to 1. Okay? So the sum of all the probabilities of all possible outcomes. So out of 10 rolls, or you can see, 10 flips. Okay, the sum of my heads, sum of my tails is 1. Okay, so that's going to actually help us find certain probabilities. So, like, for example, the probability of event A happening plus the probability of what we call not A. Okay? So we can call, let's say A was heads, not A had to be tails. So heads plus tails has to equal 1. Okay, if I subtract P of A from both sides, I'm going to get, so if you get a question that you want to find the probability of not something, all you have to do is calculate that something and subtract it from 1. Okay? And I'll be referring to this a little bit later in our discussion here. Okay, so for example, let's go back over here. If I know my probability of tails is 0.7, and I want to know what's the probability of not tails, then 1 minus 0.7 would be 0.3. Okay. All right, so let's talk about some applications here on the next page. Okay, so I know there's a lot of notes here without a lot of examples, but remember that this can be put on your workbook check, okay, or a video check, sorry, which is basically, have you watched the video? It's not just did you do some math, but are you listening and writing down, taking notes? So with that being said, let's go to number 1 on the next side. Okay, so I'm not going to do all of them here. We will do some in class. So a jar contains 20 marbles. Okay. So when we talk about probability here, we're going to talk about theoretical probability, okay? We're not going to actually do experiments with this. This is just favorable over possible. So once you know this information, this is your total number you're going to use over and over again, and your denominator, okay? And then these guys here are your events. The event of drawing a yellow marble, the event of drawing a green or red marble, for example. Okay. All right. So we have 10 red, 3 green, 5 blue, 2 yellow, and that adds up to 20. So we have counted for all 20 marbles. And so the way we write this is since I'm already stating what the event is, I'm not gonna write P of yellow marble. I'm just gonna P of E. Okay, so the event in this case is a yellow marble, and we have 2 yellow marbles over 20 total. Okay, and so this is the work that I want you to show when we do this in class. So 2 over 20 reduces to, if you divide both of those, and some calculators can actually do this for you, it's going to be 1/10. Okay, what is 1/10? Okay, the probability is 1 out of 10, or 1/10. But in normal conversation, we don't really talk like that. We actually take the decimal version of this and we say, okay, 0.1. 1/10 is 0.1. And then we move the decimal 2 places to the right for a percentage, and we say basically 10% chance. Okay? So we kind of skip all that and we translate that to 10% chance. So we have a 10% chance, not very likely, of drawing a yellow marble. Why? Because there's only 2. There's only 2 out of 20, so it's not very likely. Okay? So what is more likely than all would be the 10 red, because there's more of them. There's about half. Okay, that's about 50% chance right here, because it's half. Okay, so let's move on to C. So marble that is not blue. Okay. All right, so remember, the formula that I just showed you guys was, if it's not something, you can actually just calculate that something and subtract it from 1. Okay, so what is the probability that it is blue, and so subtract it from 1, because you're basically asking for the other half of the probability, so, or the other side of it. So basically, as a shortcut, I can say, okay, the probability that it is blue would be 5 out of 20. Okay. And if I get a common denominator, I need it in 20s. I need this 1 to be 20 over 20. That's a 1. But I need it to be 5 over 20, so that's actually 15 over 20. Which is, if you reduce that by dividing by 5, then you're going to get 3/4. Okay. So that's one way to do it. So the other way to do it would be to actually list all the colors that are not blue. So we could actually do it that way. It's a little bit longer, but we could say the probability of everything that's not blue would be 10 red plus 3 green plus 2 yellow. So that's 15 over 20. And then reduce it down to 3/4. Okay, so you could do it that way as well. Okay. All right. Blue, red, or green. So blue, red, or green. So the probability of blue, red, or green is going to be, so we have 5 blue. We have, 10 red and 3 green. So that's 18 out of 20. Which, if you reduce that by 2, it's going to be 9/10. Okay. So even though these are the answers, we can translate these to, hey, that's 0.75 or 75% chance. This is 0.9 or 90% chance. Okay. All right, so let's go ahead and take a look at the other page. Okay, here we have the words. The letters of the word Tallahassee are placed on cards. If one card is selected, what is the probability that the card is a vowel, the letter S, the letter A or E, consonant? So I'm going to do, so let's go ahead and count. All right. How many total letters do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 11 total letters. And that's the number we're going to use in the denominator. So basically, the probability of a vowel, so that's my events. So how many vowels are there? Well, we have 3 A's and 2 E's. That is 5 vowels. over 20 total. So that's 5 over 20, which reduces by 5. So that's going to be 1/4. Whoops. I'm looking at the wrong thing here. Sorry about that. 11 total. This is just 5/11. And so this is 5 divided by 11 on our calculator is about 0.45. So that's definitely close to the middle. Gonna do C, so A or E. It's gonna be, we have 5A or A's, sorry. So 3 A's and 2 E's. Same thing. Because those are all the vowels, okay? Next we have number 3. I'm not going to do this one, but just think of parts of a circle or pie, okay, whatever image, pizza. So what does this represent? This is what does this represent? What does this represent? Okay, and that should help you do that one. And let's take a look at number 4. In an election for student council president at Southeastern, 50 students, okay, were polled and asked whom they plan to vote. So we know that's our total. The table shows the result of the poll. Okay. So if one student is selected at random, determine the empirical probability that the person planned to vote for. So this is an experiment. Okay, we got the result of the experiment, 20, 10, 5, and 15. And so Lauren, probability of voting for Lauren, in this case, would just be 15 out of 50. Okay, which needs to be reduced by 5. That's going to be 3/10. Okay, what does that mean? Probability is 0.3 or 30% chance that Lauren will be chosen from this group. Okay, and depending on if this group represented well Southeastern, and we could make some predictions about the whole population, but that's more advanced than this class. So anyways, 30% chance for Lauren there. And then Andrew or Jackson. Okay, Andrew is 20, Jackson is 10. Add those up, you get 30 out of 50. Divide those by 10, and you have 3/5. Okay. Now, any person except Michael, you can add them all up, or you can do probability of not Michael would be 1 minus probability of Michael. So you don't have to do it this way, but you can if you want. Okay. All right. And here's the answer key. So take a look at that and work on your assignment online. Okay, let me know if you have questions. We will see you in the next video. So the next video is going to be at 1.4. I'm sorry, 11.4. Okay, so right now we're focusing on 11.1 and 11.4.